now. Okay, let's start our course now. Yesterday, and we had learned the first materials. First materials are driving force of the 5G evolution, and the development of 5G protocol standardization, and the 5G industry tree and the ecosystem, and the 5G global commercial development play. Okay, let's review yesterday's content. And you know, the first is okay. Wait a moment. Okay. Yesterday, we have learned IMT 2020. This is the official name of 5G. 5G official name of 5G, and this name defined by ITU, ITU, and sorry, wait a moment. Okay, IMT 2020, and the challenge in 5G areas. One is ultra high throughput, and ultra low latency, and the ultra large connection. This is the ITU's target in vision. And for EMBB scenarios, we need reach the ping rate can reach 10 Gbps, 10 Gbps. And for URLLC, we need meet the 1 millisecond end-to-end latency requirement. And for MMTC scenarios, need 1 million connection in 1 kilometer square. This is the ITU's vision. Compared with our 4G and the ping rate enhanced, and the delay is shortened, and the connection is larger. And why we need 5G? There are one typical application: AR, VR, and MR. VR means virtual reality. And VR, there are three modes. One is VR glass, PC VR, and cloud VR. PC VR, we know PC VR should use the local computer to process the video. It's not very convenient. And it's very expensive. If we want to go site, we can't take the big computer with us. So is not convenient. But for cloud VR, and we just have buy a terminal, and then all the video, all the process, all the GPU and CPU will be in the cloud, and we just use the terminal like the VR glass, just see the HD video. So the terminal is more cheaper and more easier. So the cloud VR, maybe in the future will be popular. And the cloud VR need a high throughput, or 5G can meet his requirement. Another is augmented reality in some in some games, in some like education, we may use the AR. And the development of 5G protocol standardization. Now the R50 and R60 have frozen. And the R50 this version focus on the EMBB scenarios. EMBB scenarios. And at the beginning time, like China deployed the 5G network based on the R50, the NSA network, NSA network, and let's see the phase point 1.1, and the phase 1.2 focus on the SA, and R60 due to the pandemic, so it's later, and at July 3rd, this protocol R16 also have frozen, and R16 will focus on the EMBB plus URLLC, and some MMTC. MMTC. This is a protocol situation. And for SA networking, one is NSA. NSA means non-standalone. NSA means the 5G and NR were deployed with the 4G, and the 4G, yes, the 4G base station is the anchor, and goes through the signaling, EPC, and the 4G base station LTE, and the NR, UE, EPC. LTE is the anchor, and the NR is the data split. And this is the NSA. Actually, it's option 3X. Now, like in China, the operator deploy NSA, use this option 3X. And for this mode, just can support the EMBB, scenarios. And for NSA, NSA standalone can support EMBB, URLLC, MMTC. And the enhanced 5G security from the algorithm, from the encryption of user imagery, and end-to-end protection between the PMN and the user play integrated protection, and compared with the 4G and the 5G security is enhanced. And 5G industry tree and ecosystem. You know, our 5G equipment, 5G chipset, 5G terminal, and 5G frequency band is already like a chipset, like Huawei Helixcom, and the Qualcomm and the sensor. This company have pushed his release his 5G chipset, 5G terminal, and the government also issued the 5G frequency band to the operator. And 5G global commercial development play. The first wave focus on the EMBB scenarios, like AR, VR, like HD video, like the HD broadcast live, and some public security. We can use the 5G and the camera for the city monitoring, and use the big bandwidth to back home the HD video to the command center for the public security, and explore more application in vertical industry. You know, our 5G, 4G focus on the customer, and for the user, person to person. And for 5G, we are focused on the vertical industry, like for the intelligent manufacturing, like in the V2X, like in the port, like in the police, and so on. 5G will enable vertical industry. So for industry, we must have the URLLC, and MMTC, these two scenarios we focus on in vertical industry. Okay, this is the yesterday's content, just review, and we can do some practice.
Trainer Dirk, can you send us this chart? I find it really useful.
You mean this document?
Yeah, can you send it to us?
Okay, after class, I will send it to the Huawei local staff, and then he will send you. Okay.
Yeah, thanks.
Okay, and let's make some quiz, and you can write your answer. You can write your answer. And you can write answer near in this file. Okay, and you can click on the top of your computer and click this button and click click here, and you can write your answer after your name. For example, if you think this answer is A, you can click. You can write your answer A. If it's B, you can click B. Okay. I hope everyone can write your answer on this on my screen. On my screen. Okay.
Sorry, could you please repeat it? How we can write
on the top of the screen, you can see there is a button, annotation. Okay, annotation. Have you seen here?
Which one? Which one, please?
This one. Annotation on the top of the screen.
View options?
Yes, it's good. Yeah, view option. From view option, go to the annotate.
Yes, annotate. Yes,
yeah.
And then you select the right, the left button, and then you can write your answer. You can try. Yeah, very good. Yeah.
This one.
Yeah. Okay. Let's see the first one. The formal name of 5G is IMT 2020, which was defined by ITU, and this is right or wrong. You can write your answer on this.
How can I find my name? How can I find my name?
You can't find your name?
Yeah.
No problem. Just write your answer if you can't find your name. This is choose or false.
Yeah, it's true.
I think it could be better if you activate the chat box, you know.
Yeah.
It's better. It's easier for us.
Uh-huh.
I'm not finding my name. My name is Jalal. Could you help me?
Okay, everyone can write your answer on my screen. I just want to make some communication with you.
Yeah, but I think my name is not exist.
Doesn't matter. Doesn't matter. You can tell me your answer. It's right. It's true or false.
It's true.
True.
Yeah.
Okay, the answer.
And regarding the second one is B.
Could you help me my name? I think it's not exist.
Okay.
Sorry?
Let's see the first one. The answer is
True.
Is true. Yeah. It's true. Yeah, it's true. Okay. Let's see the second one. Yeah, for EMBB scenarios of 5G, the ping rate is required to reach which one?
10 gigabit per second.
B.
10 giga.
giga.
B.
Yes.
Yeah, the right answer is B. B. Okay. And the third one, based on the version defined by ITU on 5G, how many connections should be supported in 1 square kilometer?
1 million.
1 million.
1 million.
1 million.
Okay, 1 million. Yes, perfect.
1 million.
And the first,
C, lower latency.
the multiple choice.
Low latency.
C.
The right answer is
All of them.
Low latency.
Right, it's wrong.
Except D.
ABC.
A, B, C.
All of them.
okay. Right, the right answer is A, B, C. Yeah,
PC, yeah.
yeah.
ABC.
The last one. To realize the general version of 5G on 5G, what application scenarios have been defined by ITU? The right answer.
D,
ABD.
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 Yeah. The right answer is ABD. Perfect. I think everyone has digested the content. Okay. Let's say it's a small quiz. Let's continue our course.
Sorry.
Please.
Yes. My name is not exist in the list. What's the wrong for that?
Don't in the list. Didn't
Yeah.
in list.
Jalal. Can you help me, Jalal?
You can send your name to the local Huawei local staff, and they may update the or teacher list. Okay.
Okay. I will check with Dr. Jihan.
Yeah. You also sent your name to the Huawei local staff, and this document is from the Huawei local staff. Yeah.
Okay, thank you.
Okay. Let's see. Continue. 5G network architecture and the key technology. New architecture. Okay, and this picture, I think your every teacher have know NSA and SA. This is a NSA mode. Just the EMBB scenarios is supported, and LTE is the anchor point. Go through the signaling. Go through the control signaling. And but for this mode, the 5G kind of provide continuous coverage. If the UE here, and the 5G, the 5G base station provide the network service to the UE, provide the 5G service. But if the UE go out these areas to the LTE, then LTE will provide the network service to the UE. And we can see here. I have set the EPC and the LTE their control plane. CP control plane. And why? There is also user plane here. User plane. I have said all the user plane goes through EPC to NGC. EPC to the 5G NR. To the NR. But why? For LT, between LT and EPC, there's also the user plane. There's also user plane. Yesterday, I have introduced like this. Introduce just the LT, just go through the signaling and a 5G base station is the data split. Data split and go through and send the user data to the UE and also the LT also send the user data to the UE at the same times. This is also called the MSA. Multiple stream aggregation. And now why this is EPC also have the user play. We can discuss. You can explain your opinion.
Excuse me, hello.
Yeah, please.
Yeah, this is for continuous coverage because in non-standalone 5G base stations would not be available in everywhere. So and all terminals in this case should be embedded with the 5G and LTE transceivers, and this can provide dual connectivity between 5G and LTE. So that's why if in somewhere 5G doesn't available, so the smartphone, the terminal should be process or change the point of attachment to the LTE network. So this is just to confirm transparent and seamless mobility for the users. But I have one thing, in terms of the control plane and why control plane is, if you look at it's communicated through LTE network. In LTE network, LTE base stations, the control plane latency is very high. For example, when someone wants to switch on its mobile phone, so it's almost 60 to 80 milliseconds. It takes about 60 to 80 milliseconds until the LTE, the smartphone receives the LTE coverage. This is the control plane latency, and we have also data plane latency. But I'm just wondering why, for example, the control plane latency is not it's not provided through 5G. Why it's provided through LTE? Because control plane latency, in 5G there are two objectives in order to provide 1 millisecond end-to-end latency. One of them reducing the data plane latency from, in LTE it's about let's say about 20 millisecond, reducing this data plane latency to almost 1 millisecond, and also control plane latency, because in LTE control plane latency it's approximately within 60 to 80 milliseconds.
Yeah.
So how we can bring down the control plane latency, that's why this is the main concern in the research community. I think it's
good. First, one reason is that our 5G. One question. The first question. 5G is not continuous. So if UE out of the 5G areas, the LTE 4G base station provide the data service to the UE. This is one reason. Yes. And another reason that if the UE in the 5G base station, 5G NR coverage area, when the UE make a call in the 5G areas, and then the UE null out the 5G NR. Actually, in our 4G, we use the VoLTE, VoLTE means HD voice or HD voice. If we just use the 5G user play, provide the service to the UE, and if the UE come out the 5G areas, may when the UE is calling, may the UE maybe interrupt, maybe no service, and the user may complain the service. So we also need like user play in our go through our LTE and EPC. This is another reason. Maybe in the future we just have the VNR, VONR, maybe in several years later, NOVR. And the third, you said NSA, you know, the control plane latency is very high, really, right? Control plane, the latency is high because you use the 4G network, maybe 16 to 18 milliseconds. Yes. But I have said the NSA network just support the eMBB scenarios, not URLLC. So 4G network have a higher latency. It doesn't matter. It just support the eMBB scenarios. LTE base station have deployed very well, and the operator can't deploy the SA network directly because it need bigger money, it's bigger investment. And in the earlier stage, most of the users just need a high throughput, don't need the URLLC. So NSA mode is enough to provide the service. And maybe several years later, if the application become more and more, especially in vertical industry, they need like a V2X, they need a low latency. So the operator need to deploy the SA network, SA networking. In China, the government, the operator have announced now they have started to deploy the SA networking.
I think China Mobile, to the best of my knowledge, they started to deploy SA.
SA. Yeah. Okay. This is a 5G networking scenarios. And for SA, you can say support the eMBB, URLLC, MMTC, and network slicing. And NSA can't support slicing. Only SA can support the slicing. And high requirements for the continuous coverage of 5G. 5G. Maybe in the future we achieve the automatic driving. The network must be continuous. Otherwise, if there's no network service, and may cause accident. Okay. This is SA.
So both LTE. Hello.
Please.
LTE. I mean, this one is it connected through wire or wireless? I mean, LTE and 5G anchor G node B in the figure at the left hand side.
Can you repeat? Sorry.
Yeah, I'm saying that the 5G G node B, 5G NR,
G node B, yeah.
Is it connected through wire or wireless to the LTE E node B? I mean this one.
This one.
Yeah.
Through the optic fiber. Yeah. This is a X2 interface. X2 interface.
I think it's radio over fiber.
Yeah, optical fiber. We call it X2 interface.
X,
And the NR and the NR between NR and NR, we call it XN interface.
XN, yeah. Oh,
Yeah.
yeah. Okay. Thank you.
Okay. Please.
Again, it's radio over fiber, I think. Otherwise, I think that just for a note, this fiber optic is radio over fiber, ROF.
Sorry, which part?
The new technique in fiber, radio over fiber, ROF.
Okay, sorry. ROA?
ROF, radio over fiber.
Radio. ROF.
Yeah.
Radio of fiber.
Radio over fiber. ROF. Yeah.
ROF.
Yeah.
Radio of fiber.
Over fiber. Yeah.
Mm-hmm. Radio
The
of
connection.
fiber.
The connection that Mr. Kayhan asked.
Radio. Radio of fiber.
Yeah.
Radio communication, like through fiber.
Yeah. The two base station communicate through the optical fiber. Yeah.
Yeah. Okay. Thank you.
Okay.
Yeah, just go ahead. It's okay. Thank you.
Okay. Let's continue. Continue. Okay. This is SA networking. SA networking. SA networking. SA networking. You know our 4G networking. You know our 4G or 4G networking. For example, 4G is E not B. 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 And between E not B, we call it X2 interface. X2 interface. X2 interface. And for control plane, for 4G, it's MME. Right? Yeah, MME. And for user plane, it's P gateway. And S gateway. This is for user plane. User plane. Okay. MME. And P gateway. P gateway and S gateway. User plane. User plane. And
excuse me.
Please.
What is XN or X2? What is the meaning of this interface?
Yeah, it's just the name between the interface between the input B between the two input B, like the S1 S1 interface for control plane, the S1 for user plane. Yeah, it's just the interface between the two network elements.
Okay, thank you.
Yeah, like S1. X2, like ME, M1, M2, like SN, NGC, NGU, UU interface. Yeah.
Okay.
Just the interface. For 4G, MME and E node B is the S1 for control plane. And also have the S1 for user plane. This is our 4G 4G's network architecture, right? 4G network architecture. But for our 5G 5G network, You know, the core network will based on the cloud. Based on cloud. Based on the cloud. Based on the cloud. And actually the architecture is similar to the 4G, but the core network is some differences. Some differences. And for core network, all network element will become the function. F means function. AMF means access and mobility management function. UPF means user play function. User play function. All the function will be deployed on the cloud server. Cloud server. And you know why the 5G network can support slicing. One reason is that the core network based on the cloud. And the MME become the AMF. This is the control plane. AMF. You know, in our architecture, network architecture evolved, and the control plane and the user plane are separated from the 2G, 3G, 4G to 5G, and the control plane and the user plane separated. And our MME function is converted into AMF, like this one. MME mobility management to AMF, and user authentication to the AUSF. This is all network elements is a function. F means function, and the session management converts into SMF, session management function, and peak gateway session management also are converted to SMF, and the user play data forwarding to the UPF. You know, we can see this see this picture, and the function is more dedicated compared with our 4G, like the AMF just responsible access and mobility management, and AUSF just responsible for the user authentication, and for 4G, all network elements divided into each function. So it's more dedicated, like HS into UDF, like UDF. So this and more completed separation, more completed separation. More completed separation, and because it based on cloud, all the function deployed on the cloud server, this is the 4G 5G architecture. Have any question? Hello?
Thank you.
Okay.
Yeah, or 5G core network where use the IT infrastructure, not a dedicated device any longer, because it's very flexible. If you want a large capacity, you just insert the server. So just insert the disks. It's very easy. You just install software. So this is the difference. This is the key difference. Clearly?
Excuse me. This
Please.
is, yeah. No, these functions, all of them are like embedded in the NFV, I mean, network function virtualization at the
NFV,
backhaul. At the backhaul, right?
Backhaul.
Yeah.
Backhaul. What's the backhaul?
I mean, you know, in the app core network, all these functions is embedded. Yeah. So and each of them are serving the slices, right? Or you know, it depends on the type of the slice.
Yeah. Your point is
the point is that for example, these functions in where these functions are located at the core network. So in the core network you have, you know, yes, you have cloud, but you have, you know, like central cloud, you have like fog cloud, and you have also edge cloud. And in Huawei, you know, the names are edge, local, and central cloud or data center. So these functions are located in which part? Is it located in the edge, in the fog, or in the cloud itself?
This function is can deploy which depend on your need. If user plane, if we want to deploy the user plane, the core network user plane nearer application, because for the security issue, for the latency issue, so you can deploy near application, near user. You can also deploy in the core network, in the core layer. It depends on your service. It's very flexible.
Okay.
Yeah, and you know, the software will be decoupled with hardware. You know, core network is just the server, just the software. Is decoupled decoupled with hardware. So it's very flexible.
Sure.
Yeah.
Thank you.
Okay. Let's have a short break.